Hi, everybody. Welcome to session 3. We have received many questions about how the proposed flood measures work, how they will impact the adjacent communities, including what will they look like, what other types of measures that could be used, and what are other cities doing. To answer these questions and more, we're joined by a great panel. Edgar Westerhoff, the U.S. Climate Adaptation Solution Lead at Arcadis, Justine Shapiro-Klein, an associate at One Architecture and Urbanism, and Luis Bassetti from Jacobs, American Coastal Lead. Edgar's going to kick us off, and then Justine, you're welcome to jump right in.
Yeah, very good. Thanks for the introduction. And let me share my screen. Yeah, can you see my screen?
Yes, we can.
Perfect. Yeah, thank you. Well, I think we have about 15 minutes each to go through quite a bit of material after our review of the HEADS study. So I'll jump straight to it. See if I can advance my slides here. There we are. So quick agenda, some HEADS observations. I'll be touching on New York City's climate resilience preparedness. What have we seen past a decade? What are we talking about when it comes to climate risk, also longer term planning efforts? And I would like to touch on some Dutch water management best practices when it comes to engineered solutions, but also the interplay with natural solutions. I've tried to embed some of the questions that were asked to us in the slides, so you will see those listed where possible. But Amy, I think we have some time afterwards to discuss questions as they come. So, maybe a first observation here. When I saw this image presented, I was like, wow, this is a really mature attempt to bring the various strategies together. The strategies the city has been working on for well over a decade, but also now combined with what the Army Corps has been doing. So really a great attempt to integrate the planning strategies from past decade. And that's exactly, I think, what we need to accomplish here. Also, what occurred is the interplay and how strategies are being combined. So when we talk about coastal strategies, the onshore strategies, but also the barrier solutions that would happen offshore, it's all part of a coastal strategy, which was not necessarily the case in the past when we were discussing various strategies independently without showing, I would say, the systems interplay. I think what very well speaks to this plan also is how the conversation around storm surge barriers has matured. And I think that is not in the least because of processes around the core, like ice storm, to which many specialists contribute out of the UK. We have Jacobs in this presentation as well, also out of the Netherlands, and a lot of specialists within the Army Corps, contributing to bring knowledge to the table. And I think this strategy, the HEADS plan, is showing an evolution of that. I think the plan is also raising questions to us, not just the community, but people who are working with these strategies, because we all know that if any strategy, say 3B, were to be implemented, knowing that it takes several decades, there's still, work to be done. Resilience planning is a continuous process, so it won't stop. Also knowing that with the time ahead of us, the circumstances may change, and with changing circumstances, we will also need to adjust planning components. A big question I think many of us have is, what about backflow issues, the drainage, the outfall issues? We already see those challenges throughout the region. And with, say, 1 or 2 feet of sea level rise, that will only get worse. And, many of the structural, the engineered solutions around coastal protection are not going to stop that. So we need that additional layer of defense to mitigate those negative impacts. I think a very needed question to discuss, what about the communities that are not covered by a plan? We have 520 miles of coastline. New York City has been working on long stretches, but there are still also with the core, with the HEADS plan, many communities that currently don't have a plan. And not having a plan means that, in a few decades from now, and not having a plan, not receiving a plan, means that we need to think about ways to maybe to upzone and slowly move away from coastal zones, low-lying coastal zones that may be inundated. So these are just a couple of positives and also questions to the HEADS plan. So let me get to some of the risk thinking here. I think many of you have seen these images. This is how water is creeping up in Lower Manhattan. This is part of the FIDI, the Financial District study. It shows when water is going to break the waterfront edge, but really more into the future, 2100. I think the real threat here is that we are looking and planning for 2100, but the situation is getting worse rapidly. And I think that is what is speaking through this more detailed image. Especially the second column here. Water is going to break the waterfront edge, and this is for the FIDI Financial District area around 2050. And that is, I think, very relevant to many other places. And I've just put a circle around this. The Rockaways, Coney Islands, Newton Creek, Jamaica Bay, you name it. Many places that even don't have a waterfront edge at the elevation of 4, like we have in Lower Manhattan, will see inundation at that time. So what is our approach to that? And I think that's a level of refinement that we will need to see throughout the region. So take a quick step back. I think it was touched upon earlier in the call. This has a long history. It's the barrier conversations, the structural engineering around this has a past with Malcolm Bowman and his team of specialist international contributions through a competition. We've been studying barriers for a long time. At that point, it was quite like an independent observation, so it didn't necessarily include some of the community resilience strategies that have evolved past decades, but nothing is new. I think at that time, at the beginning, definitely post-Sandy, it was also quite politicized. The Bloomberg administration, many people had an opinion about these kind of strategies, and I've posted the QR code. It will bring you straight to that one pager that kind of explains why barriers are a bad idea. Well, I think there was some misunderstanding why we have a storm surge barrier in the first place. It's to keep storm surge out of this region. And it will not protect you against sea level rise. So that is, I think, a definition that has been clarified also through HEADS. It's matured as part of a comprehensive strategy. One of the first studies where this has been assessed more comprehensively through a community lens was the Coney Island Creek Barrier and Wetland Feasibility Study. So also here, we did study various barrier alignments, but in tandem with how natural strategies could work to mitigate some of the, of the lesser favorable aspects that can come with a barrier, like erosion. Also bringing the strategies on land and explaining what a tie-in into the community means. So I think through these kind of exercises, putting these large engineered solutions in perspective, in a comprehensive way, it's part of a grown-up evaluation. So a few words about what we are doing in Manhattan. I think, Justine, you will touch on this in your presentation as well. The highly complex environments that we are dealing with. We have to retrofit strategy solutions. This planning has been going on for about 8 years as a refinement for the big U section of Lower Manhattan. The first phase is currently being constructed, East Side Coastal Resilience. This, you can say, is the second phase, Financial District. Well, the complexities, of course, speak through this plan, but you also see how solutions can take shape. And this is, I think, touching on several of the questions, Amy, that we received. And I'm posting that right in here. So how can protection be integrated in the existing landscape through parks and other features? I think this plan is a great example. It's also a very high-end example. So we need to acknowledge that there will be parts in the city, around the city, that may not see a solution as well developed as this one, with multifunctional use of space, bringing amenities to a place where we currently don't have a lot of amenities. But definitely lots of lessons learned through the planning exercise that has been going on through the Big U. Another image that came out of the extensive studies here, what are the implications of these kind of engineered solutions? Well, it was a question that was asked, are there any downsides to bring in these strategies? I think a short answer to that is, of course, we have to study that through the hydraulics. This is an image from the East River, and you see the top image, how financial district with one of the initial studies we did, a 500 feet built out, how that is impacting the currents at this place, at this location. You see the speed of water, and there's not a lot of impact. We don't see wave reflection or wave impact across the East River in, say, Red Hook. But of course, this needs to be studied more thoroughly. I included this image. I found this in one of the presentations that was online. I mean, this is really a fantastic overview image that is showing so much. And of course, your eyes is being pulled to the alignment. You see the barrier alignment, you see the constructed zone within the community. But I think it also speaks to multiple lines of defense. It doesn't stop with a alignment. There's also natural features here. This is Jamaica Bay. We've been studying Jamaica Bay over time. The Corps has been studying Jamaica Bay with the New York District. An example of building with nature, natural strategies can be, for example, shallowing of the bay, which reduces the impact of waves, which is a fantastic amenity to have during a storm surge event. But there's much more to this, and I posted. Oh, sorry. Oh, I think the question will come after this one. So we will touch on that hopefully in the Q&A more. So a few words about the Netherlands, lessons learned, water management best practices. And what I did is, bring a snapshot of the many strategies that we have in the Netherlands, also acknowledging that we've been working on these strategies for hundreds of years. So this is not something that happens overnight. And I think this example speaks to that. You see multifunctional use of space. You see a primary levee system. The bottom left is Katwijk. The Dutch government had to upgrade this primary system. And the way that was done is by integrating parking in this dune landscape. So it has a very natural appeal, but it also is resolving the parking issues that the community used to have. So it's a levy solution that is also contributing to the community financially through parking, beautifully embedded. And I think it speaks to a couple of the questions that we received about multifunctionality and what it means to live at the coast. And here you see another example, Dakpark in the city of Rotterdam. I think this compares to the planning that has been going on for Manhattan, also multifunctional use of space. How can you provide water safety in an environment that needs to be upgraded and as a result can turn a community around. This has been a very successful implemented strategy in the city of Rotterdam. Here you see a call out of Katwijk again, with also the sidelines in between the dunes. And this is the question I touched upon earlier. What is the value? Why do communities and people want to live in these kind of places? Of course, it has to do with the beautiful location that you're in, but we also acknowledge that water safety, it comes with a trade-off. A trade-off that relates to bringing in elevation. But if it's done right, and I think this is a good example, if it's done right, you preserve the values of being and living in a place like this. Storm surge barriers, a lot has been discussed. I think a short observation, if the Dutch were to plan for resilience again, they would not start with barriers like they've been implemented as a result of the Delta Plan. So after the 53 floods, there was a political decision made that would not happen again. And the result was a 40 to 50 billion euro program established 15 billion established over 40 years. But this is not how the Dutch would start from scratch again, because there's quite a few downfalls to including these kind of engineered solutions. I'll touch on a few of them by highlighting the Maasland barrier. This was the latest accomplishment as part of the Delta Works, established in 2000. This is a very busy navigational channel. So it was very much about, how is this channel being used? How can we provide access into one of the busiest ports of Rotterdam? So navigational opening, shouldn't provide any obstruction. Also limited obstruction when it comes to water outfall through the Rhine Delta. So there's a lot that comes with these kind of engineered strategies. I think this is also included in one of the visuals that we've seen for an in the heads plan. Building of nature is something the Dutch have been practicing to navigate, to mitigate some of the negative impacts. This is the Markerwaard, where Rijkswaterstaat, the equivalent to the US Army Corps of Engineers, is practicing with building of nature features to alleviate some of the downfalls. And I think the emphasis and what we are currently learning is the benefits that come with these kind of strategies, building of nature, economic benefits, ecosystem benefits. A lot of this is currently being done in the New York area as well. Living breakwaters is a great example off the coast of Staten Island. It's a great example how alignments as a hybrid solution as a whole can bring and increase resilience to a region. So, bringing things together, it's not about one solution. It's really about skills of intervention and connecting the various skills in a comprehensive strategy. And back to my initial observation, I think the HEADS plan is a fantastic accomplishment that is really trying to get there with the many questions that are still at the table. I think with that, I have one final image. I discussed, the challenge of retreats. I think, Justine, you will also touch a little bit about the processes that we've been part of and the process that New York has learned, how do we work with communities? Big part of that has to be about, painting an honest picture to communities. What is your plan and can be your plan if you live in a community like this? I believe this is the Back Bay in New Jersey. We may not see a solution for these kind of barrier communities. So this is also where over time we may have to consider retreats and places where investments will not be made. So community engagement process is also needed very much for these kind of places. And I think that's a level of refinement that we still need to see. With that, Amy, I'll give it back to you and to the next speaker.
Yep. We're ready.
All right, I'm going to go ahead and share. Let me know when you can see. Good.
All good.
All good? Wonderful. Hi, I'm Justine Shapiro-Klein. I'm really thrilled to be with you all today. And what I'm going to talk about is from the perspective of our practice at One Architecture. We work as urban designers and planners on many flood infrastructure projects in New York and elsewhere in the US and abroad. I'm going to talk a little bit about design considerations. I think this is not going to be so specific to critiquing any of the design proposals that are part of the tentatively selected plan, but more how do we as designers approach these questions of how to fit flood infrastructure into urban fabric or into urban areas. And with that, the goal of finding places of alignment or opportunities to create better, more livable urban places at the same time. And so these are some of the considerations I'm going to walk through. It's kind of a toolkit if you will, or an approach to how we would consider designing a new flood protection project that I think will help give some tools and language to approach the Army Corps' proposal. And there's a very large toolkit for thinking about climate adaptation, and we work with a range of climate impacts, from flooding to stormwater management to heat and other seismic, et cetera, other risks. I'm going to focus today really on coastal interventions, because this is what we're here for, the Army Corps proposal. And I'm going to focus a little bit more on the graphics on gray infrastructure side of things, because you're going to hear from Luce in a moment about green infrastructure, engineering with nature, and nature-based solutions in more detail. So I want to avoid some overlap there. So these are some of the components that we start to see in the Army Corps proposals. So at the beginning of any project, I'm going to go through the considerations, but we're working with a kind of toolkit of flood protection strategies, and we try to define the full universe of options in order to understand what specifically might be a consideration in any given project. So one of the first steps in the design process is really about establishing criteria and establishing a prioritization framework. So, for example, how do we assess when a design proposal, when a flood protection project is succeeding? So in the HAT study, we have some clear criteria around avoided damages. So that's physical damages and avoided economic disruption. But I think more broadly, we can think about the success of a project in terms of its constructability, for example, how spatially feasible it is, the timetable to implement that project. Or, for example, is it single purpose or multi-purpose? Does it deliver multiple benefits to its communities? Is it adaptable to be changed over time? And then with that, we can begin to get into the design of flood infrastructure. So this is a kind of matrix of options from a past project that starts to look at what could flood protection infrastructure look like. For example, if we are evaluating different options for changing the elevation of the coastal edge, for changing infrastructure and embedding flood resilient infrastructure with that, or flood protection with that infrastructure. If we are redesigning stormwater management at the same time, and I'll talk a little bit more about stormwater specifically in a moment. And finally, the shoreline itself. If we are holding the shoreline, working back from the shoreline out into the water, Luce will talk a little bit more about the space that's required for different kinds of interventions, from kind of the bulkhead or seawall being in plan, taking the least amount of space, to solutions like living shorelines that really require much more horizontal space. So I think there's also a question about levees or berms. And what we see is typically the design of a levee or berm, the maximum slope is what controls the footprint that intervention takes in space. So if you have a 1 to 3 slope, which is kind of the maximum angle that you might consider for soil or planted vegetated surfaces, that could be a very relatively compact footprint. But if there's space, for example, if there's an intervention on a wider beachfront shore, you might be able to expand that slope. And with that expansion, you create flood protection infrastructure that's actually more accessible, because it's easier for people to go up and over a low sloping surface than it is a kind of steeply sloping surface. So this is also part of our toolkit. Another really important consideration is whether we are creating more problems with the flood protection infrastructure that we are recommending or that we are proposing. So when we put barriers along our shorelines, we have to think about the drainage that's happening behind them. So these are 2 examples of a hypothetical coastal edge where you have sea level rise, where you have a surge event. There was a question about drainage, and our sewer system in New York City is really designed to drain by gravity to the waterfront. So when water levels are higher than those outfalls, we have backups along city streets. And that effect can be even more challenging and even more damaging if we have raised coastal edges, because then we're not only having inundated neighborhoods, we're potentially holding water behind the barriers. So we have to plan for both sides at once. These are a few examples just from a previous study in East Harlem looking at dispersed stormwater management approaches in a neighborhood. So thinking about redesigning the coastal edge and at the same time looking for places and ways to hold water. And we have to do these two things at the same time in order to become more resilient. The next consideration is about timelines. So where we are right now in 2023, and Edgar just mentioned this, we're talking about planning, we're talking about infrastructure that will by design take years, decades to be implemented. And we need to be aware that sea level rise is continuing and increasing. And so we need to be planning not just for where we are today, but where we'll be in the future. And ultimately for the obsolescence of that infrastructure. So, any project has a kind of design flood elevation or a level of protection. And we have to recognize that there may be a point in the future that makes that obsolete, and understand that if we are putting things in place now, we want to ensure we're not actually making ourselves in a more dangerous or more vulnerable position in a few decades or at the end of the century. So then I'm going to get a little bit more into neighborhoods. I think many of you have seen or played with, investigated the Army Corps story map. So this is a graphic from that website. And what we see are lines on a map. But a line on a map actually has spatial implications at that location. And when we think about what that means as we experience it in physical urban space. And the other thing I want to point out is just that while we're talking about coastal protections, typically in flood protection projects, it's not only a coastal protection, but also a tie-in, which is to say you have to connect from the waterfront to higher ground to create a flood protection compartment that maintains that higher elevation at all sides. Otherwise, we have a lot of water. It simply just goes around the coastal edge. So it's not enough, as you may already know, it's not enough to raise the coastal edge. We have to connect it back into urban neighborhoods. And in New York City, those neighborhoods look drastically different. New York City and New York State, New Jersey, throughout the region, depending on whether it's a barrier island, whether it's a dense urban edge, whether it's a hard shoreline or a soft shoreline, an inland waterway, or facing out onto New York Harbor. So those site conditions really dictate what can and can't work from a technical perspective. And that is in addition to thinking about the local fabric and the design of a specific neighborhood and what we want for our communities. So these are just two examples I like to bring from the Gowanus Newtown study now almost 10 years ago, that when we think about going back from the waterfront and into neighborhoods, that flood protection has to negotiate all of these other challenges. So it's not simply the line on the map, but it's how do we integrate that infrastructure with emergency infrastructure, with access to homes, with basic services in the city, with light. So this is in a residential neighborhood, or similarly in an industrial area, the sidewalk, on-street parking, utilities, access to buildings. And I think in all these projects, one of the ways that we can try to arrive at outcomes that are beneficial for communities and for the city or for the state is going back to those project objectives and really understanding, are there opportunities for alignment between a flood protection project and other initiatives that are going on in a neighborhood? So this is an example from the East Harlem plan, where we were looking at not only open space assets in the neighborhood, but the community assets, community priorities, and then in addition to that, flood protection. So all of these things together can inform what makes a good solution or a great solution for a neighborhood. I'm just going to finish up quickly by showing some graphics. These are really all renderings from previous work, but just to highlight in each case a few key points. So here, Edgar already showed an image of this South Street Seaport and Financial District area. But I think one of the things we see is that flood protection doesn't always mean a single line, and that there are opportunities to pull it apart, to build in levels, to bring people down to the water, and to create new views and even amenities and recreational spaces. So we can think really creatively, and the more space we take up horizontally, oftentimes the more creative solutions we can find in terms of creating places that people want to be. This is another view from that project looking toward the water. Again, thinking about what kinds of spaces are we creating at the waterfront? What do we need in a neighborhood beyond protection against a flood event? Do we need green space? Do we need access? Do we need bikeways? Do we have aspirations of restoring natural ecologies? Lucy's going to talk about that a little bit more. And this is another view looking at how do we rethink infrastructure or get people to the waterfront edge and maybe make connections that don't exist right now from a neighborhood to the waterfront, and use flood protection infrastructure to do that. This is an example. This is from a Nantucket project, so a little bit less dense than many of the areas in New York City, but thinking about both the everyday and the storm event. So how can flood protection infrastructure enhance the experience of the everyday, the public realm, as well as performing? And in many cases, if we're not talking about an elevation that is multiple stories above grade, there are ways to integrate flood walls, integrate levees, other infrastructure into the public realm, so that those features almost become invisible in some cases. But that's about, creative thinking and advocating for where a flood protection alignment can go in order to minimize the impact of the public realm. And then last, this is an image from a Vancouver project. This is actually an inland waterway, but really imagining if you can create space at the edge, how can you provide space for restoration, to daylight historic watercourses and buried streams, to reimagine the entire experience of the waterfront with recreational and nature-based assets. And here, what you don't see is the flood protection, because it's by pulling it back from the edge, a little bit like in the previous example, it's more able to be integrated into the urban fabric. So it's kind of invisible to this rendering, but envisioned within that first line of buildings. So these were some of the questions that I was posed. I think we've covered most of them. And I'm really looking forward to Luz's presentation, looking more at nature-based solutions and the Q&A. Thanks so much.
Thank you, Justine.
Thanks, Justine. I'm gonna start sharing my screen. If you can see it. Not yet.
Coming up. Great.
Okay, let me move. It's time. Okay, well, thank you so much for being here today. So we received a lot of questions from you. Some of them were recurring topic about nature-based approach. Is nature involved in this consideration? What's going on? Are we addressing multiple risks, multiple benefits? So I'm going to try to answer some of these questions. Let me see if this is still in the screen, I think. And to be able to do that, I'm going to actually back up a bit, and I'm going to go and give you a few definitions of some of the words you might have read in a HAT report. And I think it's important that we all start on the same baseline and understand what is going on and what we're working with. And also that will give you some tools to better understand what flood protection were presented and what else can be done. And I will finish this presentation with a few local examples in New York City, in the New York, New Jersey area, and one in UK in the Thames estuary. All right, let's go to the next slide. Let's set up some baseline. So those definitions are very important, and that's the reason I put them back here, the definition of just text. And the reason they're here is because they're all coming from the lesson learned nationally and internationally. By that, I mean that the first definition I'm going to give to you is on the upper left of the screen, and that's engineering with nature. And you might have heard a lot about this in the recent years, because really, lesson learned is that you need to work with nature and not against it. If we work against nature, we're going to lose and nothing is going to work. And that includes gray solution. The gray solution, there was a lot of question about it. Gray solution can become greener, and I will explain that in the next few slides. So the reason we're going into working to engineering with nature and not against it is that all the solution will deliver not only environmental benefits, but economic and social benefits. And that's really what we're looking for. And we're doing all things through collaboration. To understand its benefit, we need collaboration. And that's why we have this session. This is exactly what we're doing now. It's a collaboration, hearing your question, answering your question, and trying to raise additional questions that you might not have thought about yet. The next one is multiple line of defense in the lower left corner of your screen. And that's something Justin has been talking about right now. It's very important. Multiple line of defense means that we do understand the need of balancing solution to better protect our community and your communities against multiple risks or hazards. And those risks could be coastal or riverine erosion, it could be groundwater, coastal, tidal type of flooding. So this multiple line of defense is a very important concept. Just by putting one solution is not going to protect the community or its neighborhood. The next one is risk reduction feature. It's a term you might have seen in the Army Corps report. It can become very confusing, but really what it means is that it's a set of solutions, back to multiple solutions. But in that instance, it's to reduce the risk of impact when the flood barrier is actually closed. So solution to this could be, for example, considering pumps to maintain the interior drainage function behind the levee of the barrier. Or it could be more natural features such as a dual purpose park ready to store water. Again, if you remember some of the rendering we've been seeing so far, this is a kind of approach to it. Finally, coastal system. And that's something maybe that, was not communicating as well as it should have been, or maybe that's a misunderstanding, but the goal of this report, of this study, is really to look at the system as a whole. So it's really important we do understand that each community have to address their own risks, and they will have their own solution. But to be stronger, all these community and stakeholders really need to work with one another, otherwise it's going to create silos, and it's not going to have any regional benefits. So raising your issues with your own community is very important, but working all of them together, you will realize that some of your neighborhood is very much alike yours and have the same kind of issue and the same kind of approach you need to take. I will finish this slide by saying something that might be a bit not great for some people to hear, but gray solution, what is being called gray solution, which is defined as a human engineered structure and includes steel of concrete, like a floodgate, right? Does not make them bad for the environment if they actually designed the right way, and if you understand the benefit of having them on a big picture, on a regional scale. And that's why I will present to you at the end the example of the Thames estuary flood barrier in the UK that have been operating for the past 40 years very successfully. All right. I don't know if you see the top of my screen. I don't know if you see this bar, but hopefully you don't, and you see the full slide.
I think just a slide.
Just a slide, brilliant, because I have a black, so anyway. All right, So I'm going to give you some tools, as you know, for your own neighborhood. And that's something that's maybe before, a lot of questions where, what can we use? Why not nature-based? What's hybrid? Can we flood-proof? What's going on with elevating? And I think that's all very fair questions. So to be able to actually, summarize all these issues you might have, the best thing to do is to answer by yourself and with your communities and with your stakeholders. This is a question that we need you to answer to us: is who do we need to protect, right? Is it a regional-based solution? Are we talking community-based or even site-specific based solution? And that's very important you understand that, because a lot of questions were site-specific, which is very important, but then start saying, okay, my site-specific, how does it go with the community? How does it go with my regional solution? An example of a regional scale protection system is 16 miles approximately flood protection barrier in St. Petersburg in Russia. So the barrier was put to test actually in 2012. They had the 4th highest flood event reported in history for the city. And the gates were closed. And to be honest, like largely, most of the population was largely unaware that the flood event had even occurred. And the city was protected thanks to this flood barrier. An example of more local to you all, which is maybe more like a community protection, will be what's happening in the Rockway Boardwalk reconstruction project. That's approximately 5 miles of boardwalk that were very heavily damaged, really, like not directly by Hurricane Sandy in 2012. And the new boardwalk is actually now serving as a waterfront and recreational amenities, and is basically at the same time of bringing the social and the environmental benefits to it. It also protects against a 100-year storm event. All right, when you understand who do we protect, what do you protect from? So in this specific study, we're protecting against a 100-year storm. So we're all on the same page, because there's some misunderstanding about that. A 100-year storm means that there is 1% chance of a flood event occurring in any given year. And I think it's important to understand that, because 100-year return period doesn't mean that we're not going to have only one event in 100 years. And also understanding what do we protect from? Are we looking at event like Hurricane Sandy, or is your community needs to look first also into nuisance flooding, which is a condition that occurs usually during normal or exceptional high tide in very low-lying area. So you need to understand what needs to be done now and what needs to be done in the future. And then you go back to the question: how do we protect? Passive versus active measures. This is some of the solutions Justin was showing you earlier in the slide. When do we need to protect? Another very important question is like, is that something that needs to happen like now? And why does it need to happen now? Or do we have time to actually create another type of solution that might take longer, but will protect a new layer of solution for the future? And the final one is, how do we maintain the protection? There is a lot of guidelines in New York, New Jersey area about how to maintain structures, infrastructures. So this is something that's been very much looked into, and that's in place, and that's working brilliantly. So all of those questions will guide you to the best approach. This is something you need to understand. And the last thing about this slide will be on the right bottom corner. This is a type of solution you're going to hear about every time you hear about coastal protection. You can do structural, like the floodgates we've been talking about. You can have natural, which is more like wetland restoration type of project. Hybrid solution, which combine everything. And a non-structural option. Non-structural, that means getting some new policies in place, right? And that's aligned with the retreat, the problem of maybe started talking about retreat in some neighborhood. This is a non-structural option. It's still a solution, but that's going to need a lot of discussion and a lot of involvement from a lot of parties. All right. Another important thing to remember is space, and that's what Justin was saying. Is it is very important. I mean, depending on where you're living in a study place, right? New Jersey, in New York, it's all about space. And I wanted to show you this example of Lake Pontchartrain in Louisiana. This is a graphic from the Basin Foundation that they put together in 2006. It's a perfect example of what if you have space, because what they've been doing is that they were able to use 11 lines of defense to basically protect not only the community, but the assets. Of these 11 solutions, 5 were natural and 6 were man-made. But simply put, when you look at this kind of solution with different line of defense, is that the wetland will protect the levee, which in turn will protect the people and its infrastructures. So it's about space. So when you come in an area like downtown New York, in Manhattan, you can really see that there's not much you can do, but you still can go more green into the solution you actually putting into place. And the next slide, I think, will maybe help you understand what I mean by hybrid or what I mean by enhanced existing structure. So on the left-hand side, you have what the traditional engineering solution looks like: bulkhead, seawall, concrete stairs. And the more you're going to the right, the more you will use a solution including bioutilization, biomimicry, which just mean enhancing existing structure and leveraging organism and biological material to mimic nature. Those solutions that you can see on the right of the gray, so I don't know if you see my mouse, which something where you see living seawall, for example, right here, are what we call enhancing existing gray infrastructure. Actually, living seawall is a perfect example. The seawall is existing, but the ecological benefits of a seawall is very minimal. So you end up in a situation where these tiles were created in such a way that the shape of these tiles, and you can see on the figure, and done in such a manner that they help the environment come back to the seawall and create this new layer of natural enhancement, right? Then to the right of it, which is the living shoreline and the dunes and the rock seal in front of wetland, it's a hybrid solution. They are a mix of gray and green solution. At the bottom, you can see the rock seal, and the seal, basically this rock in front of the vegetation, are acting like a barrier. They're protecting the new planting that we put in place that will promote, and it will promote the growth of the vegetation and protect it from small wave events. So this gray infrastructure will actually help protect the green infrastructure in the back to grow through time and get stronger. And finally, on the right-hand side is a green solution. The one that's supposed to preserve, that will preserve and restore the environment. It's wetland restoration, like you've been seeing in Jamaica Bay. There was a lot of wetland restoration being done. There's oyster reef, that can be a solution. When you come to this kind of solution, though, you need space. And in a lot of places around New York, New Jersey, space is obviously a constraint. It doesn't mean that those solutions cannot be used. However, let's make it clear, natural solution like this will not stop a 100-year flood event. They will help maybe break waves and lower the energy of the water coming into land. But the water level will not change. You will still get a wall of, of a 100-year flood event coming at you. Another important thing is that when we work and with this engineering with nature, which is part of the core of engineering, the nature positive aspect to the project is taken into consideration when you talk about environmental and social benefits. Let me see on time, I'm okay. All right. So I'm going to conclude with this graphic, which I think is a good one to always remember when you talk to to other people about what you learn and what needs to be done. For a system to work, a resilient solution for adaptation is unlikely to be exclusively green or gray. It's going to be more hybrid solution, especially in this kind of area we're talking about, and the scale of the project or the solution you're going to put is really also depending on the space you're going to have. So this graphic, let me get back to this graphic, right? At the bottom of the screen, let's start with the bottom. At the bottom of the screen, you see the word communities, stakeholder, funding, and policy. That are very important role. This is you. This is all you today like actually caring about that, because it's a pillar of the system. And that's what you've seen in Miami, right? The community stakeholder, I mean, the solution presented was not working, so the system just collapsed. It went, and they decided to go to another direction that was more aligned with what was needed. So at the top, the arrow at the top is a green to gray spectrum of solution that I was showing you earlier. That's all the type of solution you have. Again, green, wetland restoration, soil restoration that will dissipate wave and tidal energy. And then you got the hybrid, which might be a seal in front of it to protect this green solution. And you can end up in a gray solution, which is a floodgate, for example, that needs to remain a permanent gray really for their essential function. So the size of the rock represents the hybrid green and gray solution for the whole system, the system we're talking about. If you remove one of the rocks, the system doesn't work anymore. It starts being imbalanced. So all the solutions depend on one another to work efficiently. So you need to look at the regional. The floodgate might be needed. The storm barrier might be needed. But on a local scale, you're still going to need to have maybe a greener solution or an enhanced solution to actually balance the benefits of having a floodgate. Let me go, and we're running low on time. So I'm going to go quickly about things you've seen in your neighborhoods, hopefully. There's a lot of community scale projects that have been ongoing already and even finalized. Those include the East Side Coastal Resiliency project. It includes the Rockway project or the Hunters Point Shoreline Stabilization project in Queens. If I take an example let's take the example of Hunter Point Shoreline Stabilization in Queens. The problem in this location was space, right? But that didn't stop the designer to go ahead and still install a wetland, did a wetland restoration. And you can see there's a slope to it. So there's a rock revetment that actually protecting this wetland. And this rock revetment can sustain a 100-year flood event, the energy that a 100-year flood event will bring to the rock. So it will not be impacted by that. However, with the elevation of the water, the wetland will get flooded. And it is okay, because this is part of the solution. Let the water flood the wetland and then keep going in a step kind of approach, same way Justine was showing her at the end, and make the land as high as possible to basically linked to the 100-year elevation that's needed for the design. So a lot of the solution, like this one, is meant to be flooded. The one in Rockaway, you have a very nice, promenade now. You have some dune restoration with very nice planting in place to basically maintain the dune in place in case of storm events. Yet again, this is designed for 100-year storm events. And this is actually tied up to the solution that you'll be seeing with the flood barrier. All right, let me go to the UK and talk about the Thames estuary. And why is it important? So why does it matter to you? Because there's a lot of similarity between New York, New Jersey, and London. There's 1.4 million residents, around 40,000 commercial property. We're talking about $400 billion of property values, approximately, of course. And it is a global financial center. This program has been ongoing for the Thames estuary climate adaptation for the past decades. So that's why we're talking about adaptability, line of defense, and all system. When they started working on this project, they're really looking to the whole system as a whole. Now, let me go to the next slide. What does it mean? The Thames barrier, which is the one to the lower left figure right here, you might have seen, which is a storm surge barrier, has been operational for the past 40 years. And to give you an idea of how much is being used, and that's the same thing as you will see, in a lot of locations, if there was some in New York, it was closed 207 times. And in 2013, 2014, it was closed 50 times because of different storm events happening. And even last year, the storm surge barrier had to be closed 7 times to protect the center of London. And it's been really critical for defending the heart of the UK economy. So this plan that you see here is not something that happened like quickly. You started with a feasibility study, And it's been an adaptive plan that is always in motion and always progressing, even now, where the UK has been, and the environmental agency has been working more and more about now that they can protect against big events, how can they make the shoreline greener? Now that they have this opportunity to actually protect this green infrastructure during major storm events. So why is it similar? This one, they have 9 barrier system, so 9 floodgates. It's more than 200 miles of structure. There's drainage pump, the nature-based solution. And on top of this, I think that's what is growing everything. There's a strong community involvement. So let me see. I wanted to show this one because it's very much linked to what Justine was talking about before me. It's the same type of map that was creating, which is lines, right? Points, dots on the map. And that's really hard to understand the full picture of what's happening. And I think that's the thing about communicating on a, on a 3D kind of visual instead of on the flat map. Is like what is showing you is like what you've been seeing in the study, in the HAT study, is points showing the tidal barriers, the linear defense, the pumping stations, the outfall, all the structure, and basically how it all works together. And I'm back to community engagement because there's a lot of things happening in this project that were put on hold until the community understood and raised a question, and everybody got on the same page about what worked and what wasn't going to work. And sometimes the community raised amazing concerns that were not taken into consideration. So your voice is very important in these kind of studies. All right. All right, so wanted to show you a bit more about what the largest program since original construction look like. And I also wanted to show you that in some location, and that's what you're gonna see with this study, is that you are working with very small space. And on the left lower corner, it is a very gray solution, but that was the only thing that was able to be done. The community understood that, and the minimum amount of money was put into this design to make it efficient, to make it protective. And the community had been working with the environmental agency and other, stakeholders to make the back of this wall more attractive with an urban approach to it, a much greener approach to it. However, this design wasn't done just, quickly without thinking about it. The steps you can see on the floor is actually to break the water and break the wave to avoid overtopping above the wall. And that's the last example because I'm running out of time. So let me do this last example. This is the Greenwich Peninsula, also in a time history in the center, like close to the Motor Financial District in London. And I thought that was an important one because that's something to also remember. We always talk about going, reclaiming land and going more into the water, seawards. But there's some instance where we need to look into the benefits of the whole. And some of the infrastructure you already have in place in a lot of neighborhood might be aging infrastructures, and you have the space limitation, but you still want to implement a green defense, right? You still want to make that as a hybrid solution to your system, which is the right thing to do. So in this situation, it was actually more cost effective to cut the original, and I'm going to point out, I hope you see my mouse, to actually cut inland. So basically work into the original bulkhead, do not raise the original bulkhead, right? Just keep it as it is and fix what it needed to be fixed to actually maintain the location, cut back, put some vegetation behind it. So the vegetation is actually better for the environment and it will help increase the flood defense to the new seawall and a new strong bulkhead, that was put behind it. It's good for water quality, which we'll be discussing section 4 of this presentation, and it's good for the fish and it's good for the people. And it's one of the solutions where don't always think that you need to go seaward. In some instance, you might need to go a bit inland to actually be able to get the best out of both worlds. So quick conclusion. Before we any discussion, and when you start asking questions to Corps engineer or to expert or the people, the panels here today, always remember, like, who do we protect, what do we protect, how, when, and how do we maintain it? And you will be surprised that you can answer most of those questions, and maybe it's going to be able to give you a bigger picture of what the problem is and what you want the answer and the question to be. Some of the question where do we, I see you, Amy, I'm very quick. The question about can we use green? Of course, green can be used. It can be used to enhance existing. It can be used on small scale to big scale, depending on space you have. And all of this green gray achievement that's going to be done and needs to be done and need to push for this really needs to be achieved for the physical protection, for the environmental enhancement, and for the big community benefits that it will have. And I'm going to stop here, and I'm going to just say one thing. Listen to session 4. Pippa Brashear is going to talk about a nature-based solution for New York City in general. So that will answer those questions about what can we use. And there's a word that she taught me during when we were doing all that, which is revive. And I think that's an amazing word for New York, New Jersey, is that how can we revive the existing environment that used to be there? I'm done. Thank you, Amy.
Thank you. And I think that this is a really good slide to end on. I think it goes to Melissa's question, and I'm just wondering if anybody else wants to comment on it. You know, we tried to demystify flood infrastructure in this session, but it seems like people may still be asking these questions: which type of flood infrastructure is best for different types of storm events, the 100-year storm event, sea level rise, tidal flooding. Does anyone want to explain that complexity?
I can start a bit, and then I'm sure Justina and Edgar would like to jump in on that. I think just the way to look at it is that the higher the structure needs to be to protect you, most of it, unless you put like a bulkhead of a seawall, something very straight, you're going to end up with something with a big, which is going to take a lot of space. And really, it's we're not trying to demystify, I think, the gray infrastructure. What we're trying to say is that depending on the cost benefits, some of the existing one, the engine infrastructure can be made greener, and there might be the best approach for a project because of financing issue, but you're still going to the right direction because you're enhancing what's existing. Maybe Justin, you have something to add to that?
I think that's a good start. I think, you know, all of these projects take layers of invention and creativity. So where we are right now is a very conceptual place. And, you know, whether it's a line, like a wall, a line on the map, or it has a larger footprint and it has more dynamic infrastructure as part of that, it's kind of an ongoing process to figure out what a particular place should have, or what a community wants to see there, and then to advocate for including these additional measures in a project.
Maybe somebody could explain the 1% chance of flooding, and if that means 1% chance today or 1% chance in the future.
So it's 1% chance today, and that's why, you know, you need to think about climate change and sea level rise and groundwater elevation, because the 1% chance today is going to change through time. So it is something to take into consideration. When you work in a coastal environment, I think it's always important to point it's not something new. And the Army Corps is very aware of that as well, because that's not something new to them. It's always included into the design you're working with, because we do know that what's happening now is going to for sure change in the future. So we're not talking about, you know, this number is the 100-year event now could become on, you know, a 200-year event in 50 years, 60 years, whatever the timeline might be. But this is part of a design. You always add some caveat to it, and you need to take that into consideration.
Yeah, and there are different ways to caveat that, right? So we can do that by adding freeboard, by saying we're not actually designing for exactly this elevation, we're designing for this plus some number of feet. We can look at, you know, additional layers of protection that might be designed in addition to an initial investment or an initial intervention. So I think another important point there is that we try to avoid precluding certain solutions in the future. So we want to look for solutions that allow us to continue to adapt, because we don't know, sea level rise is not going to stop at a certain elevation that we're designing to. So we need to understand that if it continues to progress, how do we have space or have a plan to continue to adapt?
Great. We have a question that's talking about the relative costs of different interventions, and noting that the Army Corps is using, right now, they're suggesting just a wall, where some of the images that we talked about were either more nature-based or at least was a wall with other parts of better aesthetics. Can anyone speak on the differentials in costs?
I think that's going to be tough to be really specific about that, but I guess what I'll say is that we may need to look for multiple sources of funding. So it may not be one location that is able to provide the funding for the flood protection solutions we envision.
Great. The next question we get all the time, people want to know what happens at the end of the wall. How does that get integrated into the rest of the neighborhood, into the higher elevations?
Yeah, I can start that, and just if you want. It's we have, it's at something happening also in Texas at the moment, where there's a Galveston flood barrier discussion, right? And at the same, it's like the end of the flood wall was happening. Well, the end of the wall tie up to the same elevation, right? So basically, this wall is meant to avoid water to go around it. It just doesn't stop, and doesn't care about what's next to it. And this wall is not just a wall, it's bigger design than this. There's like the pump system going with it. It's a park that may be created behind it that will, actually store the water for rainfall event as well as coastal storage event. So the wall is designed to be tied up to the same type of elevation. So there wouldn't be no negative impact of having it. So.
Yeah. I guess maybe just a quick addition. I mean, hopefully that design is taking into account the other side of the wall. It's not there randomly, it's there for a reason. So the other side of the wall may be at a naturally higher elevation already, which is what allows you to say the project needs to protect this extent versus that other extent.
Great. And two people are asking about the water table rising and or sinking. Can you guys speak to how these interventions would affect that?
So you design with these risks. I think that's the best answer, is that this is something that's happening. We know it, and it's not something new. Like you have different, and I'm going to take the example of San Francisco in this instance, because a groundwater issue is very much more prominent in San Francisco Bay Area, where the groundwater is just right there. So you actually know it's a risk and you work with these risks. So it doesn't change the type of solution you're going to have. It's just the design might be a bit different and the approach might be a bit different. But that doesn't stop most of the solution, I'm going to say, really. It's just you work with this hazard. And this is part of understanding what the risk and hazard are in each of these communities.
I think that's a very good way to explain it. Every single one of these interventions are going to be designed for the exact place where it is, given the exact conditions and for the length of time that they wish to design to. There is a question about managed retreat, and specifically about inclusive managed retreat. I don't know if anyone on this panel has the answer to that, but I just want to give a plug that Rebuild by Design is going to be working on that, actually with One Architecture and Trust for Public Land in the coming months. But I'll stop there and see if there's anyone that has some good examples of other places that have inclusive migration programs.
Yeah, and we go back to, and I don't know if the third speaker is here, but we come down to, it is a solution. We shouldn't dismiss that. And it's been successful, especially in the Pacific Islands, for example, with all this, in the Pacific, the water is rising, the need to have this retreat is part of one of the only solution, really. So it's been successful in the Pacific Island. It's been successful in some location on the West Coast in the US, in California. But it's a lot of discussion. It's not something that will happen quickly. And it will involve a lot of stakeholder and political involvement and change in policies as well. So that is this inclusivity, but the way to approach retreat. It's a very difficult subject. None of us want to hear about it if we live by the coastline, right? But it is a difficult discussion that needs to happen because I think that Edgar was showing, in I think it was Rockaway, Jamaica Beach area, Bay Area. It's the housing is by the water. So you're going to end up in a situation where it needs to be a discussion, maybe not for now, but certainly in the future, because you want to be prepared for anything that might happen.
Thank you. And last question, because we get this all the time. People want to know where the water goes. So if there's a gate, where does the water go and how are the other communities affected?
I can try to start and maybe you'll add, Liz.
Yeah, sure.
I think what's really critical when we talk about where the water goes is what water body and what waterways we're talking about. So if we're talking about the scale of New York Harbor, the amount of rain or the amount of surge that a storm event might bring is relatively smaller compared to the scale of that water body than if we talk about, say, water along an inland waterway. And so those sort of relative values are critical when we think about the impacts. Like a surge barrier that encapsulates a whole harbor has a lot more space behind it than, say, a local surge barrier that might just be dealing with a new town or Gowanus.
Okay, I think that's good.
Okay, great. We're going to give everyone just a quick 3-minute break so we could turn over to the next panel. Thank you all for joining us.
Thank you.